Very good morning, students. So today I would like to discuss about the most frequently asked questions from normal distribution. So let us see some of the questions which I had written on the board. All these questions we shall discuss today, right? So as you all know that binomial distribution, Poisson distribution, hypergeometry distribution, all these three are most useful distributions under discrete cases, right? Discrete variables. Now, normal distribution is a continuous distribution. So, you know the meaning of the continuous, right? So, where all the specific values within the range, all the values will be considered within the range. That itself is a continuous variable, isn't it? Now, this normal distribution was first derived by Gauss in the year 1809, and he has applied this theory of normal distribution just for finding the measurement of errors. That's why we call it as a normal law of errors, this normal distribution, which was derived by the Gauss, and we can call it as a Gaussian distribution also, this normal distribution. The other name of normal distribution is a Gaussian distribution, but nowhere it is mentioned in your textbook if you observe, right? Now, this was being associated with many other mathematicians, statisticians like Laplace, De Morgan. So like that, many other statisticians also had used this concept of normal distribution, right? Now, in the present modern statistics, rather than applying the normal distribution concepts, normal distribution parts, more of them were non-normal distributions were plenty, just like a discrete cases, isn't it? Now this has been implemented in many other fields to identify how the distribution goes, how the measurement goes within the certain limits. So let us have the concept of normal distribution. Let us go into the concept now. Normal distribution, as I said, it is a continuous, let x be a continuous random variable with its PDF. Look at here, PDF is nothing but probability density function. PMF confines to discrete cases, PDF confines to continuous cases. You all know that, right? The probability density function. What is that normal distribution probability density function? F of x equals to 1 by sigma root 2 by e power of minus 1 by 2 x minus mu by sigma whole square. So this is the PDF of normal distribution. Now this x lies between minus infinity to plus infinity. That is the range of normal distribution, the highest range ever. So because normal distribution is the most useful continuous distributions, this is the topmost place for the normal distribution. In all the continuous cases, normal distribution plays the vital role, remember. So f of x equals to, the PDF function is denoted by f of x, probability mass function denoted by p of x. So f of x equals to 1 by sigma root 2 pi e power of minus 1 by 2 x minus mu by sigma whole square, where x lies between minus infinity to plus infinity. This is the PDF of normal distribution, and this variate of x is called as a normal variate, and its distribution of x is called as a normal distribution. Are you clear? So once again I repeat the definition of normal distribution. Let x be a continuous random variable with its PDF f of x equals to 1 by sigma root 2 pi e power of minus 1 by 2 x minus mu by sigma whole square. Right? Here mu and sigma square variance are the parameters of normal distribution. Remember, mu and sigma square are the parameters of normal distribution. You know the value of pi and you know the value of e, right? By simplifying this, we will be distributing in the name of, in the place of x, isn't it? Which lies between minus to plus infinity. This is the PDF of normal distribution. Question number 1. Next, generally what are the examples of normal distribution? As we said that, where the possible outcomes were countable, discrete, distinct. Those are all discrete variables. X equals to A, right? But in normal distribution, we cannot assign any value to X directly. X not equals to A in a normal distribution. Only in case of that we are going to solve the normal distribution. In binomial, Bernoulli, Poisson distribution, hypergeometric distribution, all these distributions we have considered X equals to A, means specific value we have calculated in case of distinct values. But here normal distribution, it is not possible because all the values will be considered. Specific value cannot be identified. All we have to take into the consideration. That's the reason we have to consider either X less than A or X greater than A, or X lies between A to B. Only these three possible cases we have in normal distribution. We cannot calculate the probability of X equals to A directly in normal distribution. Remember guys, right? Only in case of discrete variables that is possible. In case of continuous, especially in a normal distribution, it is not possible. Finding X equals to A, it is not possible. We have to assign either greater or less or in between. So such a problem we have calculated even in normal distribution also. Now, what are the examples of normal variate? Heights of students of a college, and then weights, and then lifetime of the electric bulbs manufactured by a firm, and then marks scored by the students in an examination, where all these were falling between the range, because all the values will be considered there, right? We cannot stick to one particular value. We cannot say that in a class, who got 90, please just make a note of it. We cannot say that. We have to follow the range. Who has scored distinction, that means 85 to 100 range, right? After 85 all were distinction only. We cannot specifically say only 85 is a distinction value, right? Distinction mark. 85 and above, so more than 85, all are distinction. 60 and above, all are first class. 35 and above, passing class. Below 35, failure class. You understand guys? Either more or less, but we cannot say specifically exactly particular value is only the passing value, particular value is only the failing value, not like that. 35 up to 34, from 0 to 34, this range, all are fail class. 35 to 59, all are second class. 60 to up to 84, first class. 85 to 100, distinction. So this way the range. Clear guys? So these are all the examples of normal variate. Do you understand? Next. Question number 2, which frequently asked question. Values of coefficient of skewness, coefficient of ketosis. Right? You know the concept of skewness, right? We have either symmetrical or positively skewed or negatively skewed. Only two ways we have, isn't it? So whenever exactly symmetrical, as you all know that normal distribution lies in a symmetrical curve. Normal distribution follows symmetrical distribution. Whenever it is say that symmetrical, what is the value of beta 1? Exactly equals to 0. Beta 1 value is exactly equals to 0. You understand guys? What's the value of beta 1 now? Beta 1 is 0. Now coming to ketosis. In the concept of ketosis, we have to follow the peakedness of the distribution, right? So whether it is sharply peaked, I mean more peaked, that itself called as a leptokurtic curve. Normal is called as a mesokurtic curve. Flatter top is called as a platykurtic curve. So when leptokurtic curve, always the beta 2 value is greater than 3, right? And platykurtic curve less than 3. Where in mesokurtic curve, that means a normal curve is a equals to 3. Then what is the value of beta 2? Equals to 3. So the values of coefficient of skewness, beta 1 value will be 0. The value of coefficient of ketosis, beta 2 value will be 3. You remember the concept of skewness and ketosis. Skewness is nothing but lack of symmetry, right? There symmetrical means exactly equals to 0 where mean, median, mode coincide at origin, isn't it? Positively skewed means mean greater than, median greater than, mode. Negatively means mode greater than, median greater than, mean. So this way it will be, right? Where exactly it coincide at 0, the mean, median, mode, that we call it as a symmetrical, isn't it? So in a normal distribution, when do we say it's a symmetrical? When beta 1 value is exactly 0. We can say it as a coefficient of skewness beta 1 value equals to 0 because normal distribution follows symmetrical curve. Next, coefficient of ketosis beta 2 value. So the coefficient of ketosis is denoted by beta 2. So the beta 2 value, if it is exactly equals to 3, we call it as a mesokurtic. Normal distribution follows mesokurtic curve. The normal curve follows a mesokurtic distribution, right? Mesokurtic curve, where mesokurtic means the beta 2 value will always be equals to 3. Leptokurtic means greater than 3. Platykurtic means less than 3. Exactly equals to 3. Mesokurtic, we can call it as a normal. So the normal curve follows a mesokurtic curve where the beta 2 value will be 3. So beta 1 is 0, beta 2 is 3 in a normal distribution. The coefficient of skewness and coefficient of ketosis. Clear, guys? Next, question number 3. Area properties of a normal distribution. Area properties, right? So generally normal distribution lies between plus or minus 3 sigma limits, the normal curve, where it lies between plus or minus 3. In that area properties we have the area which lies between plus or minus 1. The area covered is 68%, 0.68 value. That is the area property which lies between plus or minus 1 sigma limits. The area covered under the normal curve is 68%, nothing but 0.68. Clear? Next, the area covered under plus or minus 2 sigma limits in a normal curve is 95%. That means 0.95 something. Are you clear, guys? So literally we have proved all these area properties, plus or minus 1, plus or minus 2, plus or minus 3 sigma, which neighborhood of mu. We calculated all these three as per the normal tables. We got the values which lies plus or minus 1. The area is covered 0.68, nothing but 68% is covered within plus or minus 1 sigma limits. And plus or minus 2 sigma limits, 95% area is covered. And plus or minus 3 sigma limits, how much area is covered? 99.9%, nothing but almost 100, right? Therefore 0.999 nothing but equals to 1. The total area under the normal curve which lies between plus or minus 3 sigma limits is always equals to 1. The total probability area under the normal curve is always equals to 1, guys. So area properties means those three. The area which lies. So coming to the next question, area properties of normal distribution is completed. Now, if Z is a standard normal variate, then probability of Z less than 0 or probability of Z greater than mu or less than mu or probability of Z greater than 0. See, as I mentioned, the total area under the normal curve is always equals to 1, isn't it, guys? Now, in this normal curve, minus plus infinity to minus infinity, and this is the origin 0, right? Now, the area covered under the normal curve from 0 to infinity is 0.5, and this becomes 0.5, right? So from 0 to infinity the value is 0.5 and 0 to minus infinity is also value 0.5. The total area under the normal curve from minus to plus infinity is always equals to 1, isn't it? Now, if Z less than 0 means which side? This entire area. What is the value from 0 to minus infinity? 0.5. So Z less than 0, the value will be 0.5. The area covered, the probability of Z less than 0 value will be 0.5. Next, Z greater than mu and z less than mu. So mu means, you know that, what is the mu? Mean of normal distribution. Whenever you are taking z, that means it's a standard normal distribution. In a standard normal distribution, what is the value of mu? 0. Right? In a standard normal distribution, the mean mu is 0. In place of mu, substitute 0. Again, obviously the same value. See, all these 4 questions are one and the same only. Just they will make you confused. That's it. So z less than 0, p of z less than mu, both are one and the same. Z greater than mu, z greater than 0, both are one and the same. And all these values becomes 0.5. Are you clear, guys? So z less than 0 is 0.5, z greater than 0. Greater than 0 means which area? 0 to infinity. That is also 0.5. Less than mu, greater than mu. In standard normal distribution, the mean mu is always 0. So in place of mu, substitute 0 in a standard normal. So definitely z greater than mu is 0 and less than mu is also, this value is, mu value is 0 and here mu also 0. What is the value of z greater than mu? 0.5, less than mu 0.5. Clear, guys? So all these 4, the value is 0.5 only. Next, what is the total area under the normal curve? Just now I said 1. The total area under the normal curve is 1. This is also completed. Write down the PDF of normal distribution with mean 3 and standard deviation 2. As you know that mean is nothing but mu, standard deviation is sigma. Now in this PDF, f of x equals to 1 by sigma root 2 pi e power of minus 1 by 2 x minus mu by sigma whole square. In this PDF, just substitute in place of sigma 2 and in place of mu 3 and leave like that. They did not ask to distribute the x, just they have asked us to write the PDF. So in the PDF, substituting sigma in place of sigma 2 and in place of mu 3. That's it. Substitute and write that PDF over. After writing that, f of x equals to 1 by 2 root 2 pi e power of minus 1 by 2 x minus mu is 3 by sigma is 2 whole square, when x lies between plus or minus infinity. Just writing the PDF and leave like that. You understand, guys? PDF by substituting mean, mu and sigma value. Coming to next question. Name the distribution for which variance and SD are equal. Variance sigma square, SD sigma, both are equal to 1 in which distribution? Standard normal distribution. Name the distribution for which variance and standard deviation are equal. You have to write standard normal distribution. Just logical hint I will give you. Standard deviation and variance are equal. Standard. So immediately you think about standard normal. Standard, like that. Just logically to remember sake I am saying this. There is no logic behind this. Okay. Standard deviation and variance equal to 1 in which distribution? Standard normal distribution. This way, the word standard you remember. For the remembering sake I said. Clear, guys? In which distribution the mean and variance are equal? Poisson distribution. Remember. So there lambda. Parameter lambda, mean lambda, variance is also lambda in a Poisson distribution. But where in normal distribution, variance and standard deviation are equal in a standard normal distribution. As you all know that standard normal distribution where mean mu equals to 0 and variance or sigma is equals to 1. Then we call it as a standard normal distribution. Write any 5 properties of normal distribution. See, as we have almost 14 different properties of a normal distribution. In that, choosing any 5, best 5 you choose. For example, let us explain all the properties of normal distribution. In that you choose the best 5. Property number 1, normal distribution curve is always a bell-shaped curve. Look at here. It's a bell-shaped curve, right? That is property number 1. Property number 2, normal distribution is symmetrical about mu. Symmetrical about mu means mean, median, mode coinciding at mu, mean. Are you clear, guys? Next, that is property number 2. Property number 3 is the normal curve follows mesokurtic curve where the beta 2 value is equals to 3. At the same time, it is symmetrical, the beta 1 value is equals to 0. Here we have mentioned, look at here. So beta 1 value 0 when it is symmetrical. Beta 2 value equals to 3 when it is mesokurtic. Clear, guys? That is property number 3. Property number 4, parameters. What are the parameters of a normal distribution? Mu and sigma square are the parameters of normal distribution. That is property number 4. Property number 5. The total area under the normal curve is always equals to 1. See, what all the questions individually as a 1 mark I have written, those are all the properties of a normal distribution. Clear? Writing PDF is also one of the property. And writing range. What is the range of normal distribution? Minus infinity to plus infinity. That is also one of the property. Parameters also mu and sigma square. That is another property. If standard deviation sigma is given, quartile deviation and mean deviation. Quartile deviation is 2 by 3 sigma. Mean deviation is 4 by 5 sigma. Right? Then, if Q1 and Q3 are known, lower and upper quartiles, Q1 and Q3 are known, then we can say the mean, median, mode, all the three equals to Q1 plus Q3 by 2, average. We should calculate between the quartiles. If they ask us to calculate median, means median also the same formula, Q1 plus Q3 by 2. Mode also the same, and then mean is also same. Mean, median, mode formula when Q1 and Q3 are given, that is the average between Q1 and Q3, that is Q1 plus Q3 by 2. Next, area properties you know, plus or minus 1 sigma, 68% is covered, plus or minus 2 sigma, 95% is covered, plus or minus 3 sigma, 99.9% is covered. The area properties, isn't it? Now, the total area is equals to 1, that means 0 to minus infinity value is 0.5, 0 to plus infinity is also 0.5. So then minus infinity to plus infinity total probability value is always equals to 1. Next, when mu and sigma are given, what is the formula of Q1 and Q3? Mu plus mu minus 0.6745 sigma is nothing but Q1 value, and Q3 mu plus 0.6745 sigma. Right, from the from the mean, how much deviation? Quartile deviation. What is the quartile deviation formula? 2 by 3 sigma. 2 by 3 is nothing but 0.6745 sigma. In lower, negative side, lower. So from the mu minus 0.6745 sigma, and upper, so positive side, mu plus 0.6745 sigma, the equidistant from the mean Q1 and Q3. Okay, that is what we are calculating when mu and sigma are given. And there is one more property, the odd order moments. The odd order moments of normal distribution is always equals to 0. Even order moments means 2r minus 1 whole power of something 2r, right? So the even order moments means 2r minus 1 into sigma power of 2r, where r equals to 1, 2, 3, 4 and so on. So the even order moments, odd order moments are always equals to 0. And then normal curve is always asymptotic to x-axis. Asymptotic means which does not touch the x-axis line. Look at here. The curve does not touch the x-axis line, but it seems to be touching it, but it does not touch the x-axis line. That's why it is asymptotic to x-axis. Another thing is where the curvature take place, there the points of inflection will generate, that is mu minus sigma and mu plus sigma, points of inflection. So these are all the properties of normal distribution. Out of these, any best 5 you pick, right? And one more thing I am clearly saying, mean, variance and standard deviation, they are not 3 different properties. All 3 together should be written in one property. Remember, right? Parameter writing, range writing, mean variance standard deviation writing, and what kind of shape it is, and whether it is symmetrical or non-symmetrical, right? That one writing, and what is the skewness and ketosis coefficient values, beta 1 and beta 2 writing, and then writing QD and MD, I mean quartile deviation and mean deviation formula. And then when quartiles are given lower and upper, what the formula will be written. And next one is area properties, next points of inflection, and it is asymptotic to x-axis, and these many properties we have. Total area under the normal curve. So out of all these properties, choose the best 5 properties of normal distribution, which is asked, most frequently asked for 5 marks generally. If not for 5 marks, from those properties only, many 1 mark, 2 mark questions also there is a possibility of asking. Clear, guys? Next, define standard normal distribution. As I mentioned, in a standard normal distribution, the mean mu equals to 0, and in a normal variate which takes the mean mu equals to 0 and sigma or sigma square equals to 1, then the distribution we call it as a standard normal distribution. What is the PDF of standard normal distribution? So generally it is denoted by f of z, 1 by sigma is 1 anyhow, 1 by rho 2 pi e power of minus 1 by 2 x minus mu is 0, sigma is 1, so whole square. You understand, guys? So this can be taken as z because x is a standard normal variate which is denoted by z. Clear, guys? So z equals to x minus mu by sigma, where mean mu equals to 0 and sigma equals to 1. Then x and z are same, right? Because in place of mu substitute 0, in place of sigma substitute 1, then x minus 0 by 1 is nothing but x, therefore z equals to x. So the PDF of a standard normal is f of z equals to 1 by root 2 pi e power of minus z square by 2. Clear? Even this standard normal distribution, the total, it follows a bell-shaped curve which lies between minus 2 plus infinity. Total area is also equals to 1, and 0 to infinity 0.5, 0 to minus infinity 0.5. Almost the properties remain same. Only one thing is, it is symmetrical, where mean, median, mode coincided mu in normal distribution, but mu value is 0 here. That means mean, median, mode coincided 0. All the 3 equals to 0 in standard normal distribution. So mean equals to mu, which is 0. Variance and SD are equal. Sigma square and sigma are equal. Next, the last question. Probability of minus 0.8 between 0.8, the value is given 0.5762. Now, from this, they are asked us only 0 to 0.8. Very simple. Half of this, look at this curve. Minus 0.8 plus 0.8. This whole area is given as 0.5762. When the whole area is given, they just asked us half of this divided by 2. So directly you will be getting the value, isn't it? Half of that it is asked. 0 to 0.8 it is asked. That means only this area it is asked. The total area is 0.5762. In that half area is by 2. That's it. So with this, the normal distribution, most frequently asked questions are completed. So in the coming video, I would like to discuss 2 more distributions. One is chi-square distribution and the other one is t distribution. Clear, guys? So this is all normal distribution, most frequently asked questions. Kindly follow all the videos. Definitely it will help you to prosper in your results. Clear? So if you have any further queries, so whenever the offline session comes, we can discuss, or else one live class only we can conduct and we can clarify all the doubts one-on-one. We can interact each other. So stay home, stay safe, follow all the videos, right? Thank you. Have a nice day.